Now, when we solve, there could be more than one answer. In fact, most times there will be more than one answer. Okay? Sometimes you don't need a calculator. You can use the unit circle. If the trig equation is equal to a value that you know on the unit circle, you should be able to recognize this and say, oh yeah, that's a unit circle amount. That's in some of the points. That's a unit circle 1, 2. That's not. So we need another way to do this. Okay, so here's how we do that. First of all, first thing I'm going to say to myself is that this is a unit circle value, which means I don't have to do a heck of a lot of work. Or I just call it a UCD for short. That means I can go to the answer if I remember my unit circle. So really what you're asking yourself is, what angles have a y coordinate, because it's sine, of 1/2 on the unit circle? And those will be your answers. So if you think of your unit circle, okay, remember, we've got 3 basic values. Well, we've got 1 and -1 and 0 for these on here. But I'm not talking about those ones. I'm talking about the ones that are in here and here. There's 3 different values, right? Half, √2/2, √3/2. And depending on the angle, they go in a certain order. So remember, half is the shortest side. So what angle would have a y coordinate of positive 1/2? Well, first of all, it's going to be in this quadrant, right? Because y is positive. And it's going to be in this quadrant because y is positive. Where? 30 degrees. The y coordinate is 1/2. In this one, the y coordinate is also 1/2. What angle is that one? 150 degrees. So your answers, your solutions, 30 degrees and 150 degrees. And that's it. For part B, again, I'm looking at this and going, oh, that's a unit circle value. That's a UCD, so I don't have to do a heck of a lot of work here. I'm going to ask myself this same question, except x coordinate of -√2/2. X coordinate of -√2/2. Well, x is negative in these 2 quadrants, and the √2/2s are the ones that are halfway in the quadrants, right? So this one I know is going to be -√2/2, and then something else. This one I also is going to be know is going to be -√2 and something else. What angles are those? 135 and 225. So theta equals 135 degrees and 225 degrees. I can't do that for the next one. Okay, because it's not a unit circle value. So I can't go and find what coordinates is y divide x this. I need another method. And the method what I use, and it's described above in all those steps at the top of the page, is I call it the quadrants reference angle method. Because We need to know what quadrants our answers are going to be in, and we need to know the reference angle in order to find the angles in the quadrants. So here's how we do it. First of all, is tan positive or negative in this case? It's positive. In what quadrants is tan positive? That's when you got to remember you're all snakes talk crap. What quadrants is tan positive? 1, and it's also positive in another one. 3. I know, so that means I know one of my answers is going to be between 0 and 90. One of my answers is going to be between 180 and 270. The question is, I don't know exactly what it is yet. To find exactly what it is, I need to find the reference angle. And how do you find the reference angle? It's just the tan inverse of this value, but always positive. This is already positive, so I don't have to worry about it. So you're going to find the tan inverse of 0.3. Okay, and that's going to give you the reference angle. And notice that it says, and I'm getting you used to this now, because on the provincial exam next year, you're going to have to answer to 3 decimal places. So if you do this on your calculator, you should get 16.699 degrees. Got the 2 pieces of information to find the answer. In quadrant 1, if this is the reference angle, what's the actual angle? In quadrant 1. Same thing, right? So, one of my answers is 16.699 degrees. My other answer, so that's 1. My other answer is going to be in quadrant 3. If the reference angle is this, how do I find the actual angle in quadrant 3? Plus 180. You take your reference angle plus 180. And you will get 196.699 degrees. There are 2 answers. And the nice thing is you can check them. Do this on your, do tan 16.699 on your calculator. You should get something really close to this. Do tan 196.699 and you should get the same answer. So that's one way you can check to see if you've done these ones right. Okay. So 2 types of trig equations we can solve. One using a unit circle, where basically we got to remember the unit circle to find the solutions. The other is sort of the long way with the calculator. What would this one be? Unit circle or the long way? Unit circle. Because 0 is a value on the unit circle. This is x. So what angles, I'll just write this again, what angles is x coordinate equal to 0 on the unit circle? I heard 90 and 270 is correct. Because 90 is at 0, 1. That's 0, 1. And there's another x equals 0 coordinate at 0, -1. So that's 90 and 270. about this next one? Unit circle or the long way? Unit circle. So, what am I looking at here? I'm looking at, where is the y, or what angles is the y coordinate -1? Yeah, just down here, right? There's only one of them this time. So there's only one answer here. Like I said, normally there's two. But sometimes you may get one. How about this next one? Should be pretty obvious to you. We got to do the quadrants and the referencing. So again, I'm dealing with cos, and it's negative. Cos, and it's a negative value. What quadrants is cos negative? These two, is that? 2 and 3. I've got to find the reference angle by doing the inverse cos, because I'm dealing with cos, and I have to change this to positive. Because if you don't, you're not going to get the reference angle. You're going to get some other weird angle. Sometimes you get a negative angle. Remember, when you're finding reference angle, always make this positive. Because, yeah, let's see, what would happen if you did, if I did inverse cos -0.55, I get 123.367 degrees. That's not a reference angle. Reference angles always have to be between 0 and 90. So inverse cos of 0.55 should give me 56.633. Yes? So those are the two pieces of information. Okay. Why am I throwing this out? Okay, how about from the actual angle?
180.
180 minus the reference angle in quadrant 2. And you would get 123.367 degrees. That's one answer. How do we find the actual angle in quadrant 3? Add 180 to the reference angle, or 180 plus 56.633. And we would get 236.633 degrees. Okay. Okay, the last two examples. Before you start actually solving, you got to do a little bit of algebra. We can't start solving these until cos theta is by itself. Right now, cos theta has a -1 after it and a ×2 right beside it. How do I get rid of those things? Well, what do I, in the proper order? +1 to both sides to make it 2 cos theta equals 1, divide by 2, cos theta equals 1/2. Now I'm ready to solve. Am I?
Oh, yeah, you see the.
Thank you. Yes, you do now. So, again, if you want to just sketch this to help you, cosine is a half. So that's the short one. So it's going to be here and here. Those two ends. 60 degrees, 300 degrees. Good. Here we got a few steps to get tan theta, pardon me.
Tans to one side.
Yep. So let's bring the tans over to one side. Let's subtract 3 tan theta from both sides. That will leave me with 4 tan theta, and there's still a -5 with that, equals -6. Add 5 to both sides. You get 4 tan theta is equal to -1. Divide both sides by 4. You get tan theta equals -1/4, which is not a unit circle now. But we got to figure out the quadrants first. What quadrants are my answers going to be in? Well, tan is negative. In what quadrants? 2 and 4. 2 and 4.
Oh,
Okay. Reference angle now. How do I find a reference angle? Tan inverse of +1/4. And then that's when your calculator comes into play. And you should get 14.036 degrees for your reference angle.
is it tan inverse of negative?
No, always positive. So in quadrant 2, how am I going to find my actual angle? 180 minus 14.036. And in quadrant 4, $360 minus the referencing. And those will give me my 2 answers, which work out to 165.964 degrees. That's one solution. And 345.946 degrees. And again, if you take the tan of these on your calculator, you're going to get -0.25, which means you've done it correct. Okay. Okay. So the plan